Welcome to Mind Research Rewired. We unveil scientific truths to transform confusion into clear thinking. Unlock a sharper, more effective you based on proven research. Subscribe now and elevate your life.
Welcome to the Deep Dive. Today we're plunging into a topic that's both fascinating and, frankly, genuinely unsettling: forensic confirmation bias. Imagine a big criminal case, highly publicized, and there's a suspect identified by what looks like absolutely rock-solid forensic evidence. Now, what if I told you that even the most careful scientific processes done by top experts can be subtly but powerfully swayed by something as simple as human as a pre-existing belief?
Yeah, it's truly remarkable, isn't it? How deeply these cognitive tendencies, our sort of mental shortcuts, are ingrained, and how they can seep into even the most critical systems like criminal justice. Today, we'll be pulling insights from, detailed analyses of specific cases, but also from classic psychological research, all to give you a kind of shortcut to understanding why these biases pop up, and importantly, what can actually be done to lessen their impact. Our goal really is to shed light on those subtle forces playing out when evidence is gathered and how it's interpreted.
And we're going to kick things off with a real-world example that really sent shockwaves through the justice system.
Yeah.
The case of the Madrid Bomber.
Right.
So that tragic event happened back on March 11, 2004. There was this coordinated series of train bombings in Madrid. Awful stuff. 191 people killed, about 1,800 wounded. Naturally, it triggered this massive international investigation, and the FBI, the U.S. Federal Bureau of Investigation, they positively identified a guy named Brandon Mayfield, who was an American Muslim, already on a watch list, and they linked him based on a latent fingerprint found on a bag with detonating devices. And what's really striking here is that multiple FBI examiners working independently, they all agreed on the match. Even a defense expert signed off on it.
And here's where the story takes, a shocking turn. Spanish authorities, later on, they actually matched the very same prints to the real bomber, an Algerian national named Ounen Daoud. Now, this wasn't just a simple mistake, a slip-up. An internal FBI investigation, this was back in 2006, explicitly listed confirmation bias as one of the factors contributing to this huge error. It makes you ask a really critical question. How could a lab like the FBI, is considered one of the best in the world, make such a fundamental mistake?
Yeah, exactly. And it's vital to understand this wasn't just a one-off and isolated incident. The Madrid case, alongside other things happening around the same time, like the Supreme Court trying to clamp down on junk science in courts and some scandals involving state labs, it really put forensic science under a microscope. And since then, we've learned that forensic science errors, they've shown up with, alarming frequency in DNA exoneration cases and other wrongful convictions. Organizations like the Innocence Project have really highlighted this powerfully. Studies looking at the data show specific problems cropping up again and again. Incorrect serology testimony in 38% of cases with data, faulty hair comparisons in 22%, even fingerprint comparison errors in 2% of wrongful convictions they studied.
Yeah, and this growing concern led the National Academy of Sciences, the NAS, to deliver what was described as a scathing assessment back in 2009. And their critique wasn't just aimed at, the less common techniques. It included disciplines that many people thought were basically infallible, like fingerprints, but also tool marks, firearms analysis, hair and fiber, impression evidence, blood spatter, even handwriting. The NAS basically concluded there were fundamental problems, issues with standardization, reliability, accuracy, understanding error rates, and crucially, this potential for contextual bias. They strongly advised implementing rigorous protocols, doing much more research, setting up proper evaluation programs, and they specifically recommended that these fields should really learn from cognitive psychology insights about how observers perform, how bias works.
So when we boil it down, what's the core of these criticisms against forensic science? It seems to really come down to two main points.
That's right. The first one is really about subjectivity and a lack of reliability. A lot of forensic judgments, they aren't truly objective in the way we might think. Why? Because the human examiner is, the main instrument of analysis. Think about it. Examiners are comparing visual patterns. They're deciding if two things are sufficiently similar, but often without really clear objective criteria or ways to quantify that similarity. For instance, there was research showing that if you give the exact same fingerprint evidence to the same examiners at different times, they might reach different conclusions about 10% of the time. And it's not just the final call. Some studies suggest these biases can even affect how examiners initially perceive the evidence right at the beginning.
Oh, 10% difference just by looking at it it again later. That's significant.
It is. And that leads directly to the second core criticism, biasability. Forensic experts' judgments, we now know, can be significantly influenced by a whole range of psychological factors and contextual influences. What kind of things? Well, knowing the details of the crime, feeling pressure from detectives, the fact that many examiners actually work for the police department, even things like computer-generated suspect lists, where one person might be ranked higher than others. And just the adversarial nature of our justice system itself plays a role. You see examiners getting direct communications from police in, say, transmittal letters with the evidence, or there's informal chat between examiners. Sometimes, police or prosecutors might even ask for a re-examination if the first results weren't helpful to their case. And if we loop back to that Madrid Bomber case, remember, the print was examined against a known suspect, Mayfield. The examiners already knew suspicious background information about him. Plus, the massive scale of the case, the time pressure, that definitely cranked up the psychological need for closure for an answer.
And you throw on top of that what people call the CSI effect. You watch these TV shows, and forensic science looks like magic. Completely infallible.
Exactly. That creates a really distorted public perception. And there are reasons this overconfidence persists within the field, too. Sometimes experts themselves can be overly confident in their abilities. Courts have, historically, often accepted forensic evidence without really digging into its foundations. Plus, in many cases, the actual ground truth, what really happened, isn't known for certain, so errors might not even come to light. And as we said, many examiners work directly for law enforcement, and they often genuinely believe they are objective and immune to bias. There's this pretty telling quote from the chair of the Fingerprint Society back in 2007. He basically said, any examiner who gets swayed by context is either incapable or so immature he should seek employment at Disneyland.
Wow. That's quite a statement. A real belief in immunity to bias.
It really shows the mindset.
Okay, this is where it gets really interesting, I think. To truly understand how this forensic confirmation bias works, we need to step back and look at the psychology behind it. So just basically, what is confirmation bias?
Right. So confirmation bias, at its heart, is this really pervasive psychological tendency we all have. We tend to seek out information, perceive things, interpret them, and even unconsciously create new evidence in ways that just confirm what we already believe. And it's not a new concept at all. People have noticed this for centuries. Julius Caesar apparently said, "Men freely believe that which they desire." You see hints of it in Shakespeare, Francis Bacon. Researchers point out it's implicated in all sorts of things, from everyday disagreements and historical events like witch trials, right up to why ineffective medical treatments sometimes persist.
Okay, so it's fundamental to how we think. Let's maybe explore some of those classic psychology experiments that really show it in action.
Definitely. We can start with how it affects our basic perception and cognition. There are older studies, like one where kids from lower socioeconomic backgrounds actually overestimated the size of coins more than wealthier kids, perhaps reflecting desire or value. Or another classic one. People were shown photos of everyday objects, like a fire hydrant or a dog, but they started out really blurry and gradually came into focus. What happened was people formed an initial hypothesis based on the blur, and they often stuck with that initial wrong guess even as the picture became much clearer. Their initial belief biased their ongoing perception. More recently, studies found people perceived more facial resemblance between an adult and child if they were told they were related, or they saw more similarity between a suspect's face and a composite sketch if they were led to believe the suspect was guilty before looking. And crucially, as you said before, these biases are often just natural, automatic features of how our brains work. They happen without us realizing, without any bad intent.
So it's happening at a really fundamental level, even before we start making complex judgments. That really clicks with how it could impact forensics. And it's not just about objects or simple perceptions, right? It affects how we see people, social situations.
Exactly. That brings us to social perception effects. There's something called the primacy effect. Information you get early on about someone, it weighs more heavily in your judgment. It can even change how you interpret later information about them. Like if you first hear someone is intelligent and industrious, then later hear they're proud, you might think self-respecting. But if you first heard envious and stubborn, proud might suddenly sound like conceited. This links to belief perseverance. Once we form a belief, it's sticky. It can hang around even if the original evidence for it is totally debunked. Sometimes getting more objective evidence, if it's ambiguous enough to be interpreted different ways, can actually make people more polarized, strengthening their original biased belief.
That's counterintuitive, isn't it? More evidence making bias worse.
It really is. Then there's confirmatory hypothesis testing. In a famous experiment, people tried to figure out a simple rule for a sequence of numbers, like 246. The rule was just any ascending sequence, but most people assumed a more complex rule, like add 2, and they only tested sequences that confirmed their hypothesis, like 8, 10, 12. They rarely tried sequences that might disprove it, like 3, 5, 7, so they never found the simple, true rule. Apply that socially. If you think someone's an extrovert, you tend to ask them questions that elicit extroverted answers, which then confirms your belief, even to outside observers. Now connect that to forensics. If investigators start with a hunch about a suspect, even a weak one, they might then unconsciously look for and interpret evidence in a way that makes that suspect look guiltier seem like the prime one. And worse, interrogators who presume guilt. They tend to ask more leading, incriminating questions, use more pressure, and this behavior alone can make observers judge even an innocent suspect as looking guilty.
So the belief actually changes the interaction, which then seems to confirm the belief.
Precisely. That's behavioral confirmation, or what most people know as a self-fulfilling prophecy. It's typically a 3-step dance. The perceiver forms an impression. That impression influences how they interact with the target person. And the target person, often without realizing it, adjusts their behavior in response, ultimately confirming the perceiver's initial expectation. Classic examples. Experimenters told rats were maze bright, even if chosen randomly, somehow treated them in ways that made them learn mazes faster. Or the famous study where teachers told certain students were academic bloomers, again, random selection, unintentionally gave them more attention or encouragement, leading to those students actually showing greater academic gains. The expectation created the reality.
It's really quite powerful. And it's not always deliberate, right? Sometimes it's our motivations, what we want to be true, that subtly guide us.
Exactly. This gets us into cognitive and motivational sources of bias. We know from pioneers like Tversky and Kahneman that people rely on mental shortcuts, heuristics, which are efficient but can lead to systematic errors, especially if we already have strong expectations. Then there's the idea of directional goals. Sometimes we aren't just trying to be accurate, we're subtly motivated to reach a particular desired conclusion. This doesn't mean we consciously decide to be biased. It creates what's called an illusion of objectivity. We genuinely think we're being objective, even as our preferences are shaping our reasoning. There was this brilliant study. People looked at an ambiguous figure that could be seen as either the letter B or the number 13. Now, depending on whether seeing a B or seeing a 13 would get them a desirable drink, like orange juice, versus a foul one, guess what? A significant majority perceived the figure as the shape that led to the reward. So if B meant orange juice, 72% saw a B. If 13 meant orange juice, 61% saw a 13. Motivation literally and unconsciously changed what they saw. But importantly, reality does put constraints on this. You can't just rationalize anything.
Yeah.
If the evidence is crystal clear, unambiguous, wishful thinking usually can't override it. And this is precisely why ambiguous stimuli like maybe a partial fingerprint or complex DNA mixture or unclear handwriting are the most vulnerable, and why many forensic judgments are inherently susceptible to these biases.
Okay, wow. So we've laid the psychological groundwork. It's startlingly clear how these very human ways of thinking could seep into the legal system. Let's bring it back now and look squarely at this forensic confirmation bias in action. You mentioned it often leads to tunnel vision.
That's right. So forensic confirmation bias is really the umbrella term for this whole class of effects within a criminal case context. It's how an individual's existing beliefs, their expectations, their motives, the whole situation they're in, can influence how they collect evidence, how they perceive it, and how they interpret it. And yes, a very common and dangerous outcome is tunnel vision. That's when investigators or examiners get rigidly focused on one suspect or one theory. They then tend to seek out, overvalue, or interpret evidence in a way that confirms that initial focus, while ignoring, explaining away, or undervaluing evidence that points in a different direction, maybe towards innocence or another suspect.
And this doesn't happen in isolation, does it? Sounds like it can create a kind of chain reaction.
Yeah, absolutely. That's where you hear terms like corroboration inflation, where pieces of evidence make each other seem stronger than they are. Or the investigative echo chamber, where biased information bounces around between investigators, witnesses, and experts, reinforcing itself. And the bias snowball effect is another good description. An initial biased piece of information can contaminate subsequent pieces, making the overall case seem much stronger than its independent parts actually warrant.
Okay, let's get concrete. Can you walk us through some specific examples from the research where this has been demonstrated?
Yeah.
Like with handwriting?
Sure. For handwriting evidence, one study found that ordinary people, lay participants, were more likely to see similarities between handwriting samples. And crucially, they were more likely to wrongly conclude they came from the same person if they were told beforehand that the suspect had confessed. This effect held even when they were later told the confession might have been coerced. The initial belief, planted by the confession info, biased their visual judgment. Or take polygraph tests. Inconclusive charts, the ones that aren't clear-cut. Researchers found examiners were more likely to score them as deceptive if they were told the suspect had confessed. Conversely, they were more likely to score them as truthful if they were told someone else had confessed to the crime. The external information swayed their interpretation of ambiguous physiological data.
Okay, that makes sense for things that are maybe a bit subjective anyway, like handwriting or polygraphs. But what about fingerprints? They seem so solid.
That's what makes the fingerprint research so powerful and maybe unsettling. There was a key study involving 5 very experienced fingerprint experts. They were asked to re-examine prints that years earlier they themselves had confidently declared a match in real cases. But this time, they were given some misleading context. They were told, for example, that these prints were the ones mistakenly matched to Brandon Mayfield in the Madrid bombing case, even though they weren't. Under that influence, only one of the 5 experts stuck with their original judgment of a match. 4 out of 5 changed their minds based purely on the biasing information. This showed that even highly trusted forensic science performed by experienced examiners isn't immune. Context could undermine reliability. Other studies found similar things. Just knowing a suspect was in custody led to about 17% of originally correct match decisions being changed. And looking at eyewitness identifications, this is also quite striking. In one experiment, they staged a theft. Eyewitnesses made their ID attempt from a lineup. Later, some of these witnesses were told, falsely, that another member of the lineup, not the one they picked, or maybe they hadn't picked anyone, had actually confessed. Hearing about the confession caused 61% of those who had made an identification to change their minds and pick the supposed confessor. And even half of those who had correctly made no identification initially were influenced to then select the person they were told had confessed.
Wow. So the confession information literally overwrites their own memory or judgment.
It strongly suggests it can, yes. And the fundamental problem this reveals is that our criminal justice system is built on the assumption that different pieces of evidence, suspect statements, eyewitness accounts, forensic analysis, are independent sources of information. But the research, particularly looking back at DNA exonerations, paints a different picture. It strongly suggests that, for example, a confession can profoundly corrupt other forms of evidence. One major analysis of DNA exoneration cases found that when there was a false confession, 78% of those cases also had other errors. What kind of errors? Invalid forensic science was present in 63% of those false confession cases. Mistaken eyewitness IDs in 29%. And here's the kicker. In about 65% of those cases, the false confession was obtained first. This strongly implies that the confession then tainted the subsequent eyewitness or forensic evidence gathering. In fact, the Innocence Project states that bad forensic science is the single most common type of evidence used to wrongly corroborate a false confession.
That's a really disturbing connection. The confession itself creates the evidence that seems to back it up. This brings us to an idea you mentioned earlier, the elasticity of evidence.
Yes, exactly. It's the idea that not all evidence is equally malleable or elastic when exposed to biasing information. Ambiguity is a key factor. Evidence that is inherently more ambiguous or requires more subjective interpretation is generally more susceptible. Think about eyewitness memory, it's notoriously fallible. Or degraded audio recordings where you're trying to make out words. Or those ambiguous polygraph charts we talked about. These are more elastic. But here's the really important and perhaps surprising part. Even what we consider the gold standard DNA evidence isn't completely immune, particularly when dealing with complex mixtures from multiple people. There was a fascinating real case study involving a gang rape. The original lab experts who knew the context, including that some suspects had taken a plea bargain, analyzed a complex DNA mixture and found that it implicated certain suspects. Later, the exact same raw DNA data was sent to 17 other qualified analysts, but this time they were kept blind. They had no biasing contextual information in the result. They overwhelmingly disagreed with the original conclusion. 12 of the 17 neutral analysts concluded the suspect should actually be excluded based on the DNA. Only one thought he should be included. So this demonstrates that even DNA interpretation, which many believe is purely objective and inelastic, can indeed be subject to confirmation bias when the data itself is complex and ambiguous.
That is genuinely shocking. Even DNA. It really challenges the perception of pure objectivity. Given all this, you'd hope that forensic examiners themselves would be aware of these potential pitfalls, have some insight into their own biases.
You would hope so. And research looking into this is a bit mixed, actually. Some studies found examiners do express motivations like wanting to catch criminals, feeling a need for closure, but also a genuine fear of making errors, especially false positive. That seems positive. However, another study found something interesting. Examiners working on mock murder cases reported feeling like the contextual information they were given, like gruesome crime scene photos, influenced them emotionally. But when you looked at their actual decisions, that information had no significant overall effect on their final conclusions in that particular study setup. This suggests there might be a disconnect. Examiners might perceive themselves as being influenced, or they might deny being influenced, but the actual impact of bias on their judgment might operate somewhat independently of their self-awareness. They might think they're compensating or immune when they're actually not. It's also fair to mention briefly, there have been a few studies, particularly some conducted in the Netherlands, that didn't find significant biasing effects for certain evidence types, like shoe prints or firearms comparisons, under their specific experimental conditions. The reasons aren't entirely clear. It could be that those labs use highly standardized procedures that minimize subjectivity, or maybe the specific ways they tried to introduce bias in the studies weren't strong enough, or perhaps the examiners behaved differently knowing they were in a study versus doing real casework. It's an area needing more research.
Right. But despite those null findings in specific context, the overall picture seems clear. And sadly, these aren't just issues found in labs or academic papers. This bias has devastating real-world consequences. You mentioned some cases earlier.
Yes, and these individual stories really drive home the human cost. Consider Barry Laffman in Pennsylvania. He was accused of rape and murder and was induced to confess. Later, serology testing showed his blood type was B, but the semen found on the victim was type A, a clear mismatch. But a state forensic chemist who knew about Laffman's confession didn't report the exclusion. Instead, he actually came up with 4 completely unscientific, novel theories to try and explain away the mismatch, essentially tailoring the science to fit the confession. Laffman was convicted. He spent 16 years in prison before DNA testing finally exonerated him.
16 years, based on science being twisted to fit a confession. That's horrifying.
It is. And another stark example is Tyler Edmonds in Mississippi. He was just 13 years old when he was interrogated about the death of his brother-in-law and was coerced into confessing he helped his sister commit the murder. After this confession was obtained, the state's medical pathologist submitted his autopsy report. In it, and later in testimony, he claimed, without any scientific basis whatsoever, that the single gunshot wound suggested 2 people had pulled the trigger simultaneously. This two-shooter theory directly implicated Tyler based on his coerced confession. He was convicted. Thankfully, his conviction was eventually overturned by the Mississippi Supreme Court, which flatly called the pathologist's opinion speculative and scientifically unfounded. That pathologist was later removed from the state's list of approved experts.
It's just incredibly hard to hear those stories. Lives completely derailed, and these cases really underscore that the influence goes both ways, right? Just as confessions can taint forensic evidence, bad forensic science, or other flawed evidence like mistaken IDs can actually cause false confessions too, like with Dwayne Jackson you mentioned.
Exactly. Dwayne Jackson confessed after being confronted with what turned out to be an erroneous DNA identification made by forensic examiners in Las Vegas. The flawed science led to the false confession in that instance. This really highlights the critical concept of psychological contamination. It's different from physical contamination, like getting another substance mixed into a sample, but it can be just as damaging, and it's often completely overlooked. Where does it come from? Knowing the context of the crime, as we've discussed. Pressure from police during an examination, knowing about a prior confession or an eyewitness ID. And it can be subtle, too. Even metadata from computerized systems. For example, with automated fingerprint identification systems, AFIS, they often generate a ranked list of potential candidates. Research showed the order on that list matters. Examiners spent less time looking at candidates lower down the list and were more likely to make false positive errors, wrongly matching candidates near the top, and false negative errors, missing a true match, for candidates near the bottom. The system's ranking created a bias.
Okay, so we've painted a pretty concerning picture of how confirmation bias works and the damage it can do in the justice system. The crucial question then becomes, what can we actually do about it? This isn't just about spotting a problem, it's about finding workable solutions. Our sources must offer some pathways forward.
Yes, absolutely. And that's the constructive part. The research points towards concrete reforms needed at really 2 key levels. First, changes are needed within the forensic laboratory itself and even at the crime scene where evidence collection begins. And second, reforms are needed in the trial and appellate courts where this evidence is presented and ultimately evaluated.
Okay, let's start inside the lab. What practical steps can be taken there to reduce bias?
One of the most important recommendations is implementing linear examination. What this means is that the examiner should first analyze the evidence collected from the crime scene, say, a latent fingerprint, and fully document their findings and conclusions about that evidence before they ever look at or compare it to a sample from a known suspect. This simple procedural step prevents the known suspect's sample from influencing how the unknown crime scene evidence is perceived or interpreted in the first place. The FBI, for example, has actually revised its standard operating procedures for latent prints to incorporate this approach. Now, sometimes examiners might need to revisit their initial analysis later if new information comes up, but that should be the exception. It needs to be clearly documented and justified and strictly limited.
Okay, analyze the unknown first, then compare. Makes sense. What else?
Next is blind testing, or perhaps more accurately, reducing extraneous information. Examiners should ideally be shielded from information that is irrelevant to their specific scientific task. This means insulating them from direct contact with the lead investigators or victims families, and critically, shielding them from knowing things like whether the suspect has confessed or if there's been an eyewitness ID. Their judgment should be based purely on the comparison of the physical evidence itself, not on the wider story of the case.
So keeping the context out of the lab as much as possible.
Essentially, yes. Related to this is the idea of using evidence lineups. This is modeled directly on the sequential, double-blind lineups used for eyewitnesses. Instead of an examiner comparing the crime scene sample, like a hair, to just one sample from the suspect, which is like an eyewitness show-up, known to be suggestive, you could use a lineup approach. A target blind examiner, one who doesn't know which sample is which, would be presented with, say, 6 samples, 1 from the actual suspect, and 5 plausible fillers, similar-looking samples from known innocent sources. Research, particularly with human hair identification back when that was more common, showed this approach dramatically reduced the rate of false positive errors. It dropped from over 30% in the show-up method down to less than 4% with the lineup.
That's a huge improvement, like spreading the risk of error.
Precisely. Then there's the need for controlled verification. When one examiner makes a conclusion, especially on subjective evidence, the verification step by a second examiner needs to be genuinely independent. Ideally, this means the verifier should be blind. They shouldn't know the first examiner's conclusion. They shouldn't even know who the first examiner was or be selected by them. Some have even suggested cross-laboratory verification for really critical cases, sending the evidence to a totally separate lab for an independent check.
Ensuring the second opinion is truly a second opinion, not just a rubber stamp.
Exactly. And regarding technology deployment, especially those computer systems like AFIS that generate candidate lists, care needs to be taken. The list shouldn't be excessively long, making review difficult. And importantly, the order of the candidates presented to the examiner should ideally be randomized. This prevents that bias we talked about, where the examiner might unconsciously give more weight or scrutiny to the candidates ranked higher by the algorithm.
Okay, randomizing the computer output. Simple, but potentially effective.
And finally, perhaps most fundamentally for the long term, is the need for psychological training. Forensic science education, training programs, certification requirements, they should all incorporate basic coursework in cognitive psychology. This should cover topics like experimental methods, the basics of perception, judgment, and decision-making processes, and the principles of social influence and bias. And critically, this shouldn't just be abstract theory. It needs to be illustrated with real forensic case examples to make it relevant and impactful for examiners.
That makes a lot of sense, equipping the examiners themselves with the knowledge about how these biases work. But you said reforms are also needed in the courts.
Absolutely. The lab is only half the equation. For reducing bias in the courts, a few key things stand out. First, simply educating legal decision makers, that means judges and juries. They need to understand not just the forensic conclusion, but the process by which it was reached. What procedures did the examiner follow? And critically, what information did they have access to when they made their judgment? Courts should get in the habit of routinely asking, what did the examiner know and when did they know it? They need to actively probe for potential sources of bias and contamination, especially across pieces of evidence that seem independent but might not be.
So pulling back the curtain on the process, not just accepting the final word.
Precisely. Second, if it comes out that a forensic examiner was unduly exposed to potentially biasing information before or during their analysis, then their testimony, their evidence, should potentially be subject to pre-trial reliability hearings. The court would need to determine if the exposure to that biasing information likely tainted the analysis to the point where the evidence should be considered unreliable and possibly excluded from the trial altogether.
A kind of gatekeeping function for potentially biased evidence.
Exactly. And finally, there's a need to reevaluate the harmless error doctrine, particularly in cases involving potentially biased evidence. This legal doctrine basically says that even if some flawed evidence was wrongly admitted at trial, like, say, a coerced confession or maybe biased forensic testimony, a conviction can still stand if the appeal court believes there was other overwhelming evidence of guilt anyway. The problem is this doctrine rests heavily on the assumption that the other evidence was truly independent and untainted. But as we've seen, that assumption might be flawed. That overwhelming other evidence might itself have been corrupted by the very piece of flawed evidence we're talking about, like forensic tests influenced by a false confession. Researchers looking at exonerations found appellate courts often invoke this overwhelming evidence idea to uphold convictions of people later proven innocent, people who had falsely confessed. So courts really need to consider, on a case-by-case basis, whether the original error might have contaminated the very evidence now being used to call that error harmless.
That's a complex but crucial point. The whole web of evidence might be tangled by bias. This whole deep dive really underscores how profoundly psychology and the justice system intersect, doesn't it? Often in ways we don't expect.
It really does. The research we've discussed today powerfully highlights that much of forensic science isn't purely objective machine output. It involves subjective human judgments. And because they're human judgments, they are inherently vulnerable to these well-documented psychological influences. It's clearly an area that needs much more empirical research. Doing that research won't just help improve forensic practices and make the administration of justice fairer. It also provides a really valuable real-world setting to test and refine our understanding of psychological theory itself.
What an incredibly important journey we've taken today, digging into how our own minds can subtly shape what we perceive as objective truth, especially in a field with stakes as high as forensic science. That Brandon Mayfield case, and hearing about those DNA exonerations like Laffman and Edmonds, they really go home the devastating human cost when these biases go unchecked. We've heard how seemingly small contextual details can snowball, potentially leading to major miscarriages of justice. But crucially, we've also explored concrete steps that can be taken from things like blind testing and linear examination in the lab, right through to more critical scrutiny in the courtroom to try and safeguard the system against them. It's just such a powerful reminder, isn't it, that even when we're pursuing something as vital as justice, human perception with all its quirks is always part of the process.
Absolutely. And zooming out, thinking about the bigger picture here, this whole discussion really drives home the constant need for critical thinking. And not just in forensic science labs or courtrooms, but really in any area where important judgments are being made based on interpretation. So maybe this raises an important question for you, the listener, to think about. Beyond the specific context of forensic science, how might these same kinds of cognitive biases, confirmation bias, tunnel vision, motivational effects, be subtly shaping your own perceptions and decisions in everyday life, at work, in relationships, in how you consume information? And perhaps more importantly, what steps might you take to become more aware of them, to try and uncover them in your own thinking?
Yes, that is something for all of us to think about. We have come to the end of today's deep dive. If you like the content of our podcast and learned something useful, please subscribe to support our channel. We will continue to unveil cutting-edge scientific papers to bring clarity to your thinking and elevate your life. Thank you.